Hello, good morning to everyone. I am Prakash Guruvin, lecturer, Department of Mathematics, GBR Degree College, Huinhadagli. Dear students, today we are going to discussing about the topic in numerical analysis called as numerical integration. This is for BSc 6th semester affiliated to Vijayanagara Sri Krishna Devaraya University, Ballari. Okay, let me know what is called as numerical integration. Dear students, the numerical integration, it is a process of evaluating a definite integral from a set of tabulated values of the integral f of x that we can see here. Say, if the integral is a function of single value, then that numerical integration is called as quadrature. We can say that it is a quadrature. So in this quadrature, we are going to study. There are mainly 4 quadrature rules, and those are that as given here, that is called as Trapezoidal Rule, Simpson's 1/3 rule, the third one is Simpson's 3/8 rule, and the fourth rule is called as Whittles rule. These 4 rules are very important for the examination point of view. Okay, so in today's class we are going to discussing all these 4 rules. So what it says? Okay, let me see the first rule, that is called as the trapezoidal rule. One of the very important aspect, that is called as trapezoidal rule here. What it says? So if y equal to f of x is a given function, okay, we have to consider the x value and f of x value. Okay, let x takes the values as a equal to, so x naught, x1, x2 dash one up to xn, that is equal to b. Here what is a and b? They are the intervals of the integral. That is, so a equal to, we can be divide that ab interval into n sub intervals, that is x0, x1, x2, so on up to xn. Then corresponding to these x values, y values takes as y0, y1, y2, yn. Okay, then the trapezoidal formula or a trapezoidal rule is given by, so that is integration, definite integral, that is integration from a to b f of x dx, that is equal to h by 2 into, this is y0 plus yn. This is, we are going to combining the first term and the last term of the y value, that is y0 plus yn, plus 2 times of remaining all the terms. Remaining all the terms means y1 plus y2 plus y3 plus dash so on up to yn minus 1. Okay, and this formula says a trapezoidal rule. Okay, let me know what is h value. H is a step. So how to find it? That is h equal to b minus a divided by n, where n is the given x values we can be divide into n sub equal intervals. That is, n is the, we are going to dividing the equal intervals. Okay, so it is h equal to b minus a divided by n here. Okay, by using this formula repeatedly, we are going to evaluating for any given integral value. Okay, let me see that trapezoidal rule by seeing some of the examples. Take the first example here. Evaluate integration from 0 to 1 divided by 1 plus x into dx by dividing the intervals by dividing the interval, that is interval is 0, 1 into 10 sub intervals using the trapezoidal rule. One of the very important example here. Okay, let me see the solution of this will be, let the given function will be y equal to f of x, that is equal to here 1 divided by 1 plus x, we can call it as equation number 1. So then the given interval is 0, 1. Okay, now we are going to finding the step. How many number of steps is here? That is h is equal to b minus a divided by n, that is equal to b. B is means 1, a is equal to 0. 1 minus 0 divided by 10 by dividing the interval into 10 sub intervals. Okay, that's why the formula 1 minus 0 divided by 10 here, that is equal to 1 by 10 is equal to 0.1. Okay. Okay, after this we have to construct the table, that is x value and y value. So we have to construct the table. So x values are equal interval, it means h is equal to 0.1 here. Okay, from where we have to write down here the given interval 0 to 1. So we have to start with 0 and end with 1. Okay, that is x values are 0, 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9 and lastly it is 1. Corresponding to these x values, the y values are calculated, so using the equation number 1. Okay, these x value we have to substituting in the given equation number 1. Okay, then we are getting the corresponding y values. Okay, so if x equal to 0 in equation number 1, so it is y equal to 1, 1 by 1, that is equal to 1. If x equal to 0.1, so then y value we have to calculate it as it is 0.9090. Similar way we have to calculating all these x values with respect to y values. Okay, so if x equal to 0.2 in equation number 1, then we are getting y value as 0.833. Similarly 0.3, if x equal to 0.3, y value is 0.7692. If x equal to 0.4, y equal to 0.7142. Similar way we have calculated up to, if x equal to 1, then y value is, it is 0.5. Okay, so these y values we can be denoted as y0, y1, y2, y3, y4, y5, so on up to it is last term, that is y10. Okay, so after constructing this table, we have to use the trapezoidal formula. The trapezoidal formula, what it says? So that is given by integration from 0 to 1 f of x into dx, that is equal to this h by 2 into the first term plus last term. First term is here y0, last term is y10. Therefore y0 plus y10 plus it is plus 2 into remaining all the terms. Remaining all the terms, it means y1 plus y2 plus y3 plus y4 plus y5 plus y6, y7, y8 and y9. Okay, then we are going to calculating by using the calculator here. So it is equal to h, where h is equal to 0.1. 0.1 divided by 2 into first term plus last term, that is 1 plus 0.5, that is equal to 1.5 plus 2 into, we are going to adding all these terms, that is y1 to y9, we are getting as 6.1859. Okay, if you have calculated this results, then we are getting the final answer is 0.6936. Okay, so this is the value of the integral. So it is integration from 0 to 1 1 divided by 1 plus x into dx. Okay, this is the first example. Let me take the another example based on this method only. Evaluate integration from 1 to 3, 1 divided by 1 plus x into dx by using the trapezoidal rule. Okay, the similar example which is shown here. The solution of this will be, here also we are going to dividing the given interval, that is 1 and 3, into 10 sub equal intervals. So therefore it is f of x is a function they have given here, 1 divided by 1 plus x. Here h is equal to b minus a divided by n, that is b is 3, a is 1, 3 minus 1 divided by 10, therefore it is 2 by 10, therefore that is equal to 0.2 is the difference or step value, 0.2. Therefore we can write the x value based on this h value. Okay, first we have to construct the table x value and f of x value. Okay, the x values are given by 1, 1.2, 1.4, 1.6, 1.8, 2, 2.2, 2.4, 2.6, 2.8 and 3. Okay, so corresponding to these x values we have to calculating the y values, or we have to substituting these x values in the given function, that is f of x equal to 1 divided by 1 plus x. If x equal to 1, then y is equal to 0.5, that is y naught value. Similarly, if x equal to 1.2, y value is 0.4545. If x equal to 1.4, y equal to 0.4166. Similarly, if x equal to 1.6, it is 0.3846. So on we are going to finding the y values up to the last term of the x values, that is if x equal to 3, y is equal to 0.25, that is y10. Okay, we shall use the trapezoidal rule formula, that is given by here integration from 1 to 3 f of x into dx, that is equal to h by 2 into first term plus last term, that is y0 plus y10, plus 2 into remaining all the terms, it means 2 into y1 plus y2 plus y3 plus y4 plus y5 plus y6, y7, y8, lastly y9. Okay, so we are going to substituting all these values in the above formula, then we are going to calculating, we are getting as it is a 0.2, h is equal to 0.2 divided by 2 into the first term plus last term is 0.75 plus 2 into 3.0935. Then the total answer of this will be, it is a 0.6937. Okay, so this is a second example regarding the trapezoidal rule. Okay, let me see another examples regarding the same method. Evaluate integration from 0 to 2 x power 4 plus x into dx with n equal to 6 by trapezoidal rule. Okay, so let me see the solution of this example will be, let y equal to f of x, that is equal to x power 4 plus x, call it as equation number 1, be the given interval of 0 and 2 itself. Then h value we can be find out, h equal to, it is b minus a divided by n, b is 2 minus a 0 divided by, it is n is 6 they have given, therefore it is 2 by 6, that is equal to 0.3333. Okay, by the help of this h value we have to construct the table x value and f of x value or a y value. Okay, x values are given by 0, it is each interval, that is a difference will be 0.333. Therefore, it is if x equal to 0, 0.333, next 0.666, 0.999, it is 1.3333, then it is 1.6666, then the lastly we will get it is 2 itself, that is 1.999. It is approximately equal to, it is 2, we can be right here 2. Okay, so next, corresponding to these x values, we have to calculating the y value, as if x equal to 0, then equation number 1, y equal to also 0. Similarly, if x equal to 0.333, okay, then y value we are getting as, so it is 0.3452. Like that we have to calculating all these y value by the equation number 1. Okay, so here that is equal to this y0, y1, y2, y3, y4, y5, and lastly it is y6 value. Then by using the trapezoidal rule, so it is given by integration from 0 to 2 x power 4 plus x into dx, that is equal to h by 2 into y0 plus y6, first term plus last term, y0 plus y6 plus 2 into remaining all the terms, it means y1, y2 plus y3 plus y4 plus y5. Okay, now we are going to substituting all these values in the above formula, where h is equal to 0.3333 divided by 2 into y0 plus y6, it is 0 plus 18, means it is 18, plus 2 into adding all the remaining terms. Therefore, we will get as, it is 0.1665 into 18 plus 34.1258. Therefore, the total answer of this will be given by, it is 8.6789. Okay, this is one of the method called as the trapezoidal rule. Okay, similarly we have another 3 methods. The second method will be called as a Simpson's 1/3 rule. It is also one of the very important for the examination point of view here. Simpson's 1/3 rule. Okay, what is that Simpson's 1/3 rule says? Here let integration from a to b f of x into dx, which is a given integration. Here let x takes the values. What are the x values here? So the given interval that will be a is equal to x0, comma x1, comma x2, so on up to xn, that is equal to b. The given interval can be divided into n sub-equal intervals, that is x0, x1, x2, so on up to xn. Then corresponding to these x values, y values are taken as y0, y1, y2, so on up to yn. Then we have the Simpson's 1/3 rule formula is given by, it is integration from a to b f of x into dx is equal to, it is h by 3 into the first term plus last term, that is y0 plus yn plus here 2 into, here the observe here, that is y2 plus y4 plus y6, means all we are going to adding all the even terms. Here y2 plus y4 plus y6 plus so on. Okay, then plus it is 4 times of all the odd terms. Odd terms, it means y1 plus y3 plus y5 plus y7 plus so on. Okay, this is the formula says a Simpson's 1/3 rule. Okay, one of the very important formula it is Simpson's 1/3 rule, where here h is equal to same. How to find the step here? H is equal to b minus a divided by n. Okay, so on the basis of this formula we are going to evaluating some of the integral examples. Let me see that first example. Evaluate integration from 0 to 1, 1 divided by 1 plus x into dx by Simpson's 1/3 rule, dividing the interval 0, 1 into 10 equal parts. This is a given example. Okay, let me see the solution of this example. Here the given function will be f of x is equal to 1 divided by 1 plus x. Okay, let me call it as equation number 1. So by the help of this equation number 1, we have to construct the x value and f of x value. The table will be constructed. So here x values are, it is 0, 0.1, so 0.2, 0.3, 0.4, so on up to it is 1.0, because the given interval can be divided into 10 equal parts. 10 equal parts means what is h value? H value is 0.1. Here everywhere it is difference is 0.1. Therefore we can get the x values are 0, 0.1, 0.2, 0.3, so on up to 1.0. Okay, then corresponding to these x values, so the y values are given by, here if x equal to 0, y equal to 1. If x equal to 0.1, then y equal to 0.9090. If x equal to 0.2, then y equal to 0.833. Okay, if similarly the process will be continued so on up to, if x equal to 1, then y equal to 0.5. So we are going to denoting all these y values are y0, y1, y2, y3, so on up to y10. Okay, so after constructing this table, we shall use the above formula, Simpson's 1/3 rule, that is given by integration from 0 to 1, 1 divided by 1 plus x into dx. So that is equal to h by 3 into y0 plus yn plus 2 into, so how to write? The formula is 2 into all the even terms. All the even terms, it means y2 plus y4 plus y6 plus y8 plus 4 times of remaining all the terms or all the odd terms, that is 4 times of y1 plus y3 plus y5 plus y7 plus y9. Okay, therefore if we are going to substituting all these values in the above formula, we are getting as h means it is 0.1 divided by 3 into, we are going to adding first term and the last term. So 1 plus 0.5, it is 1.5 plus 2 into, adding these values means we are getting it is 2.728 plus 4 times of adding these values, we are getting 3.4593. Therefore you are going to calculating these values, we are getting as, so the given integral value, integration from 0 to 1, 1 divided by 1 plus x into dx, that is equal to, it is 0.6813. Okay, so this is one of the examples regarding the Simpson's 1/3 rule. Similarly, take another examples. Evaluate integration from 0 to 2 e power x into dx by Simpson's 1/3 rule by taking the step 0.2. Okay, here h equal to 0.2, in everywhere difference will be 0.2. Okay, let me see the solution of this will be, let I equal to it means what? It is a given integral. So I equal to integration from 0 to 2 e power x into dx. Call it as equation number 1. Okay, here f of x is the e power x. H is equal to 0.2 they have given. Okay, by the help of this we have to construct the table x value ಮತ್ತು f of x value. Okay, then here x values are 0, 0.2, 0.4, 0.6, 0.8, then 1. Next 1.2, 1.4, 1.6, 1.8 and 2. Okay. Then corresponding these x values we have to evaluating the y values. E power 0, that is 1. E power 0.2, that is 1.221. Similarly, it is e power 0.4, that is equal to 1.491. Similarly, you have to evaluating all these values up to 2 here, x value 2, then y value we are getting as 7.3890. So these values are y0, y1, y2, y3, y4, so on up to it is y10 value. So by using the Simpson's 1/3 rule formula, that is integration from 0 to 2 e power x into dx, that is equal to h by 3 into y0 plus y10, first term plus last term, y0 plus y10 plus 2 into all the even terms. Even terms means y2 plus y4 plus y6 plus y8 plus 4 into all the odd terms, y1 plus y3 plus y5 plus y7 plus y9. So if you are going to substituting these results in the above formula, we are getting h is equal to, it is 0.2. 0.2 divided by 3 into first term plus last term, that is we are going to adding those two will be, it is 8.3890 plus it is 2 into, we are going to adding these values, we are getting as 2 into, it is 11.9896 plus next 4 into, it is 15.8664. If we are going to calculating this above result, we are getting as, it is 6.3890. This is the integral value. Okay, by using the Simpson's 1/3 rule. Similarly, all the example is of the same kind. Okay, let me see the another third method. So in the quadrature, that is a numerical integration, that is called as a Simpson's 3/8 rule. Simpson's 3/8 rule or a Simpson's 3/8 rule. Okay, so what is the Simpson's 3/8 rule says? So integration from a to b f of x into dx is a given integration. Let x takes the values. Here the given interval can be divided into n subintervals, that is a equal to x0, x1, x2, so on up to xn. So corresponding to these x values, the y is equal to f of x, which takes as y0, y1, y2, so on up to yn. Then the given integration, that is integration from a to b f of x into dx is equal to 3h divided by 8. Listen here, 3h divided by 8 into first term plus last term, y0 plus yn, okay, plus 2 into, it is a difference of 3 terms, 3 terms, 2 into y3 plus y6 plus y9, next term will be y12, okay, plus so on, plus 3 into remaining all the terms. So it is 3 into y1 plus y2 plus y4 plus y5 plus so on, continue. So this formula is called as Simpson's 3/8 rule. One of the very important formula it is Simpson's 3/8 rule. Okay. So on the basis of this method, we will see few examples regarding that. Take the first example. Evaluate integration from 0 to 1 1 divided by 1 plus x into dx by using Simpson's 3/8 rule by taking the step point 1. Okay, let me solve this example. Solution here. Let I equal to integration from 0 to 1 divided by 1 plus x into dx. We can call it as equation number 1, which is a given equation. So therefore, the given that is integration. Okay, here the function f of x equal to 1 divided by 1 plus x. Okay, by the help of this result, we are going to constructing the x value and f of x value. So where h is equal to 0.1, h equal to 0.1 difference. Okay, x values are 0, 0.1, 0.2, 0.3, 0.4, 0.5, so on up to it is 1. Similar way, we have to construct the y value. Here the function f of x equal to 1 divided by 1 plus x. Therefore, if x equal to 0, y equal to 1. If x equal to 0.1, y equal to 0.9090. Similar way, we have to substituting all these values in the f of x, will get as here y values. So those y values are y0, y1, y2, y3, y4, so on up to it is y10. Okay, so therefore by using the Simpson's 3/8 rule, so it is given by integration from 0 to 1 divided by 1 plus x into dx, that is equal to 3h divided by 8 into, it is the first term plus last term, y0 plus y10, here y0 plus y10 plus 2 into difference of 3 terms, here means y3 plus y6 plus y9 plus 3 into remaining all the terms. Remaining all the terms, it means 3 into y1 plus y2 plus y4 plus y5 plus y7 plus y8, bracket close. So this is the formula. Now we are going to substituting the above results in the above formula. We have, that is 3 into h, where h is at 0.1 divided by 8 into y0 plus y10 means it is 1.5 plus 2 into this value 1.9203 plus 3 into 4.2668. Therefore, if we are going to calculating this result, we are getting as it is 0.68030. Okay, this is the solution of this method. Similarly, take the second example. Evaluate integration from 0 to 1 into 1 divided by 1 plus x square into dx by Simpson's 3/8 rule by dividing the interval, that is 0, 1 into 10 sub-equal intervals. Okay, this is the example they have given. Here the solution of this will be, we shall see here. Let I is equal to 1 divide integration from 0 to 1 divided by 1 plus x square into dx. Call it as equation number 1 here, where h is equal to 0.1 they have given. So therefore, we shall construct the x value and f of x value. Okay, so here x values are given as 0, 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, so on up to it is 1. Similarly, on the basis of the x values, y values are calculated as, when x equal to 0, we are getting y equal to 1 in equation number 1. When x equal to 0.1, y equal to, it is 0.9900. When x equal to 0.2, we are getting y equal to 0.9615, and so on. We are going to substituting the all x values in equation number 1. We are getting the respect to f of x value or a y values. Okay, so after constructing this table, we shall use the formula, that is Simpson's 3/8 rule. that is integration from 0 to 1, 1 divided by 1 plus x square into dx, that is equal to 3h by 8 into, this is y naught plus yn, first term plus last term. Yn is 10 up to 10 intervals, therefore it is y naught plus y10 plus 2 into, so difference of 3 terms means it is y3 plus y6 plus y9 plus 3 into remaining all the terms y1 plus y2 plus y4 plus y5 plus y7 plus y8. So substituting all these values in the above formula, we are getting as 3 into h is a 0.1, 3 into 0.1 divided by 8 into 1.5 plus 2 into 2.20503 plus 3 into 4.9153, that is equal to, it is 0.7722. We are going to calculating, we are getting the result as it is 0.7722. Okay, this is one of the another examples regarding the Simpsons 3 by 8 rule. Okay, so let me take the third examples regarding the same method. Evaluate integration from 1 to 2 into 1 divided by x into dx by taking the step, it is a 0.1, by using, here the first one will be Simpsons 1/3 rule and the second method is Simpsons 3 by 8 rule. So the same similar example we have seen here. Okay, now first we shall construct the table x value and y value with respect to the given integral. I is equal to integration from 1 to 2, 1 divided by x into dx, where f of x is given by the function f of x is a 1 by x, where h equal to 0.1. Okay, it is x values are 1, 1.1, 1.2, 1.3, 1.4, 1.5, so on up to 2 itself. Similarly, the y values are calculated. So as if x equal to 1, y equal to 1. If x equal to 1.1, y equal to 0.9090. If x equal to 1.2, we are getting y equal to 0.8333. So on, the process will be continued. So on, we are getting when x equal to 2, y equal to 0.5. So we are getting the y values are y0, comma y1, comma y2, comma y3, so on up to y10. Now in the example they have asking, there are two methods. One will be by using the Simpsons 1/3 rule. So we are going to finding Simpsons 1/3 rule formula method. So by taking the result, so integration from 1 to 2, 1 by x into dx, that is equal to h by 3, formula will be h by 3 into y0 plus y10, first term plus last term, plus 2 into, that is what here, 2 into difference of that is even terms, y2 plus y4 plus y6 plus y8 plus 4 into odd terms, it means y1 plus y3 plus y5 plus y7 plus y9. Okay, this is the formula. We are going to substituting all these values. So in the above formula, where h equal to 0.1 divided by 3 into, it is 1.5 plus 2 into, it is 2.7275 plus 4 into, adding all these values, we are getting as 3.936. So we are getting as the result as 0.6931. Okay, so this is the by using the Simpsons 1/3 rule method. Similarly, they are asking in the example as by using the Simpsons 3 by 8 rule. So find the integral value. Okay, so by using the Simpsons 3 by 8 rule, the given integral, that is integration from 1 to 2, 1 divided by x into dx, that is equal to 3h by 8 into y0 plus y10 plus 2 into a difference of 3 terms, that is 2 into y3 plus y6 plus y9 plus 3 into remaining all the terms y1 plus y2 plus y4 plus y5 plus y7 plus y9. Okay, that is equal to 3 into 0.1 divided by 8 into, it is y0 plus y10 means it is 1.5 plus 2 into, adding these three values we are getting as 1.9205 plus 3 into adding these values we are getting as 4.2461. Okay, then if we are going to calculating the above result, we are getting as it is 0.68026. Okay, so this is one of the method called as Simpson's 3/8 rule. The lastly we have another method, so in the numerical integration, that is called as Whittles rule. So the Whittles rule is also one of the very important for the examination point of view. So what it says here, if integration from a to b f of x into dx is a given integration, let x takes the values, so a equal to x0 comma x1 comma x2 so on up to xn, that is equal to b. The corresponding to these x values, the y values are taken as y0 comma y1 comma y2 so on up to it is yn. Then Whittles rule says it is integration from a to b f of x into dx is equal to, it is 3h by 10 into 3h by 10 into same thing y0 plus yn, first term plus last term plus 2 into here difference of 6 terms. Difference of 6 terms means y6 plus y12 plus y18, okay, plus y24, next term will be y24, so on plus so on, plus here 5 into, we can be write alternatively plus 4 minus 2 difference, means it is 5 into y1 plus y5 plus y7 plus y11 plus so on, plus we have y2 plus y4 plus y8 plus y10 plus so on, plus the last term will be 6 into remaining all the terms. So in the above all the three terms, so that is the terms which are not there in the above three terms we are writing here, that is plus 6 into y3 plus y9 plus y15 plus so on. Okay, this formula is called as a Whittles rule. Okay, let me see few examples regarding this method. Take the first example, evaluate integration from 0 to 2 x power 4 plus x into dx with n equal to 6 by Whittles rule. Its solution of this will be, let I equal to integration from 0 to 2 x power 4 plus x into dx, call it as equation number 1. Here the given function f of x equal to x power 4 plus x, where h equal to same way. How to find the step here? H equal to b minus a divided by n. Here b means here 2 minus 0 divided by 6 means it is equal to 0.3333. Okay, that is h value. So difference will be 0.333. So by the help of this h value we have to construct that below table, that is x value and f of x value. So x values are 0, 0.3333, 0.6666, then 0.9999, it is 1.333, 1.666 plus that is the last term, that is 1.9999, that is approximately equal to 2 itself. Then corresponding these x values, y values are calculated as it is 0, this is 0.3452, this is the 0.8627, so on up to it is 18. Okay, we can mention here the what is that, here y values, y terms, y0, y1, y2, so on up to it is y6. Therefore, by using the Whittles rule formula, by using the above table, so they have given by, it is integration from 0 to 2 f of x into dx is equal to 3h by 10 into first term plus last term, that is y0 plus y6 plus here 2 into difference of 6 terms, they are not existing here, therefore that is 0, plus 5 into y1 plus y5 plus y2 plus y4 plus 6 into remaining terms, means it is 6 into y3. Okay, this is a formula we are going to using. Now substituting all these values in the above formula, it is 3 into, where h is 0.333 divided by 10 into, it is y0 plus y6, it means it is 18 plus 5 into, it is 9.7149 plus 5.353 plus 11.97. So if you are going to adding all the above values, we are getting as, it is 8.3813. The value of the integral is 8.3813. Dear students, similarly take the last example of this method. That second example will be, calculate integration from 4 to 5.2 into log of x into dx by using Whittles rule by given table. So here x values are and f of x values are given. X values are 4.0, 4.2, 4.4, 4.6, 4.8, 5, 5.2. With respect to all these x values, the y values are given by f of x is equal to, when x equal to 4.0, then the y values are 1.38629, 1.4350, 1.48160, so on up to it is 1.6486. Okay, so we are going to mentioning all these values as it is y0, y1, y2, y3, y4, y5 and y6. Therefore, by using the Whittles rule formula, it is given by integration from 4 to 5.2 into log x into dx, that is equal to 3h by 10 into y0 plus y6, first term plus last term, that is y0 plus y6 plus 5 into y1 plus y5 plus y2 plus y4 plus 6y3. So substituting all these values in the above formula, we are getting as, it is 3 into, where h is a 0.2 difference, that is 3 into 0.2 divided by 10 into 3.0348 plus 5 into 3.0444 plus 3.0502 plus 9.156. So therefore that is equal to, it is 0.06 into, if we are going to adding all these inter values, that is equal to 30.463. So we are going to calculating this value, we are getting as, so it is 1.8277. So the value of the integral is given by 1.8277. So dear students, so in today's class we have discussed about all the 4 methods of the quadrature. So one will be called as a trapezoidal rule. The second method is Simpson's 1/3 rule. The third one is called as Simpson's 3/8 rule, and the fourth rule is called as a Whittles rule. So these 4 rules are one of the very important for the examination point of view. So go through that. Thank you.